what we have scheduled for you today will take us through a couple of demos. And fundamentally, today we are going to focus on infrastructure platforms. So I know platform engineering is a very big buzzword. People are very excited about it. What we see with RackN is the operations side of the platform engineering discussion, or an infrastructure platform, where operation teams are really struggling to keep up, right? They're finding that it's hard, they're having trouble with reuse, with standards, with really driving innovation. So as much as we're helping developers, what RackN does is really looking at how the operations side of that equation is set. And we think that's a really important conversation. RackN Digital Rebar is enterprise self-managed software. So very important here. It is for enterprises, obviously, but this is also software. So companies are running their own infrastructure. We empower companies to be independent and not rely on a SaaS or opening their firewalls, really helping them on premises or in the cloud. We have a broad and deep set of customers. We'll highlight some customer journeys as we go through. And we really focus on this concept of infrastructure as code pipelines, the ability to really bring automation in a standardized, repeatable way. And it's always important for us to note, we do bare metal and go all the way up the stack. We think that it's really important to start at bare metal and treat that with excellent controls and automation, because what we really find is our customers want to be able to do their whole stack. That's what we're helping. And if you only do hypervisors or only do clouds, you're really missing out on that full IT journey that our customers are looking for. I'm Rob Hirschfeld. I will be your presenter today. My co-presenter, Shane Gibson, is here. He's going to help us with some customer journey stories, and also we're going to be sharing the demo yoke from that perspective. So, what I do want to do is give you a little bit of a framework here. Infrastructure and operations of platform engineering. Digital Rebar is our product. We're going to be showing what I call the space capsule from an architectural perspective in a lot of diagrams. It brings in an automation catalog. It interfaces to infrastructure, multi-vendor, bare metal, virtual systems, or cloud. And then we are going to be showing a Terraform, bare metal Terraform demo here for infrastructure as code tooling. And then we're going to be showing a backstage demo of showing IDP dev portals interfacing back into Digital Rebar. And if you've seen our previous conversations where we've done a lot of work showing, say, multi-site management or running Terraform from within Digital Rebar, this is actually treating Digital Rebar as an API. So we're really focused on how it's consumed by other people, not how it's used. And if you're interested in that, we have 2 great Cloud Field Day demos where we go into depth on how Digital Rebar works. We're going to be spending less time on that today, showing you more how it's consumed. And the reason we want to do that is because we see over and over again that our customers, people in the enterprise field, are really struggling to have an infrastructure platform be available, reliable, and fast. And it's absolutely critical that when we build a platform as an operations team and provide it to consumers, development teams, and other streamlined teams, that we're able to have a system that is available, reliable, and fast. And we're using dogs as the theme for this. We think it's sort of fun, keeps things light. The idea here is that an infrastructure platform first must be available, right? Because if it's not available, it must be used. And I really want to focus, because this is about enterprise, on KPIs that you could be driving or looking at to determine if you have systems that aren't available, right? Things like how often do you have systems that require manual remediation? Are the environments that you're building recreatable? And how much effort goes into having to reset those environments if somebody says, I'm going to use an environment for a day or a week, does that require administrative manual effort to go back and fix it? Or is that completely automated? Shane, do you have a customer journey that you can use to explain available?
Yeah, so one of a large financial customer sector services company had a significant challenge. They were onboarding new equipment, it was rolling out onto the operational data center floors in racks. And by the time they got through the process of submitting tickets and the networks turned up and the powers turned up and the systems guys do their thing, oftentimes they were seeing lapses of up to 6 months before equipment had landed on the floor and was being used. And that just that's a significant portion of your depreciation right there. If you have it on the data center floor for 6 months before it's used. And so the challenge there was to be able to onboard that equipment and take it from power up, from zero touch to a fully built environment that was ready to go for VMware Cloud Foundation HCL compliance, to take all of those systems and build them into VCF clusters. That's where we stepped in with a pipeline automation, zero touch workflow capabilities, classify those machines, and they'd literally power those machines on. Machines go through their post-discovery inventory process, and then once they've been inventoried and processed, apply a specific set of firmware patches appropriate to the financial institution's security compliance teams. And then BIOS configuration, hardware RAID configuration, ESXi configuration, and then a deep configuration to meet that VMware VCF HCL compliant state, at which point they're ready to be built into VCF clusters. And that process went from 6 months to from power on of the equipment in an hour. As we all know, bare metal infrastructure with power on, self-tests, and et cetera, is going to eat some of that time, firmware, et cetera. But taking that journey from 6 months to 1 hour was very critical in a lot, giving them the availability of the platforms.
Thank you, Shane. This is something that I found really powerful when we talked to the customer. Not only are they doing this internationally, so they can ship racks where nobody is, but we've now gotten the reset down into a coffee break time. So if they have to tweak a configuration or change something, they can make that tweak, hit reset, and then walk away. It's transformative, where it was 6 months or even days of work just to make a small change. Now it's literally a lunchtime, over lunch type of action. So it's also important to be reliable in these systems. If you do not have reliable infrastructure, people aren't going to be trusting it to actually do those actions. What we're going to be showing today in demos are systems consuming your infrastructure APIs. And if you're doing a Terraform or a Backstage or any type of consumer of those APIs and the system doesn't work, you will quickly find that people just stop asking. So reliability is critical for the infrastructure platform teams. And the way we look at that is, what is our success rate? How often when I do an API request do I actually get a response, right? One of the things that we talk about and we have customers doing is putting CI/CD systems talking to digital rebar. And if a CI/CD system has a high failure rate, it's going to completely gum up the works, right? The automation half-life is one of my favorite KPIs here, where if you were to ask people who are building automation how confident they are that they can come back in a month or 6 months to reuse their automation, most operators are terrified, right? Even a week after. And so the half-life of automation is actually a really easy statistic to measure intuitively about how well you're doing. But if your half-life is short, then people are going to be constantly tweaking, tuning, revisiting, or literally just not relying on the system to do its job. Jane, do you have another customer journey to talk about reliability?
Yeah, so we had a customers at one of the large national labs, and they had a significant problem. They're building an internal portal to be able to expose infrastructure to make it available for other internal customers to be able to use. And they were doing all of their build processes manually at that stage in time. And they would have someone open a ticket and say they needed a system. They'd go and build the system out, and then they would release it by closing the ticket, and then oftentimes those machines would be left behind in some undetermined state, and they weren't available to the next user. They would have to go, oh, well, this is all broken, nothing's right, and they have to go back and reset it, clean it up, rebuild the system. And so they had a hard time keeping equipment available for the user base to consume, turn over, consume, release, turn over, consume, release. And that's where we stepped in again and were able to give them the ability to drive all of that bare metal infrastructure using our platform to be able to build the machine up. The user would be able to specify some minimal set of information. It would build it to an end destination, a declarative end state. And then they would go to town, they'd use it, and then they would release it, and then the machine would go back, most importantly, through a decommissioning process that cleaned the machine up and reset it to a known good state immediately after it was released. And consequently, they're able to turn equipment over much more quickly with very little lag time between the release and repreparation of bare metal assets and making them available. We also, since we're 100% API first, allowed them to take their own existing internal portal and then integrate their look and feel and sort of skin or theme over the use of the platform so that it was given a nice, easy, glossy exterior finish that matched what their customer base was used to looking at.
One of the things that we hear with stories like this over and over again is just how powerful it is from the amount of people that are freed up from having to do this type of toil. So in the story that Shane's talking about, actually, there's 3 or 4 customer stories that are very similar to this, where they have one operator who is able to run thousands of machines through these processes and really frees up the time for them to go do higher level work because they're not mitigating or solving tickets or trying to get involved in fixing and cleaning things. And that really speaks to the last component here, where if the system isn't fast, right? We talked a little bit about bringing systems online faster, but even in day-to-day operations, when you're doing a Terraform operation or a Backstage operation or a CI/CD operation, you have to be able to run the systems really quickly, or they're just not helpful. Or people are going to do exactly what they have been doing. They're going to bypass your control systems or your governance systems and create their own infrastructure. And so it really is important to look at the time to get a system ready and available. Or one of my favorite statistics with this is the average system age, right? When I was first coming into IT, we would brag about having servers that were up for months or years at a time. But in today's IT environments, we really want to make sure the systems are turning over much more quickly, that they have a short system age. And so as you build these better processes and they're fast, then you can be confident that I'm going to take a system out of service, reconstitute it, completely reimaged, and put it back into use. If you can do that quickly and reliably with high availability, then it really does transform how you think about that infrastructure. But without the speed, you might as well just have a person turning the crank behind the scenes on this. You have another customer journey for us?
Why, yes, Rob, I certainly do. We're working with another financial sector services company. This organization in particular was they really wanted to bring on board next generation equipment. They needed to perform fast. They were doing a lot of financial transactions and trading integrations, and low latency, high speed was very important. So they were constantly pushing the edge of bleeding edge hardware capabilities. And the problem with that they kept running into is automation, when you build around platforms, are relatively brittle, and you need to be able to adjust and accommodate for changes in the hardware vendor's environment, because just like everything else in software, hardware is also iterating and getting better and getting faster, and that means changes. So they were unable to bring on board a lot of high-speed, high-performance equipment quickly, because they would have to retrench with their old tooling to be able to adjust and build new methodologies to account and accommodate for hardware changes. When we came in, and this actually speaks interestingly to the automation half-life story. So because of the automation half-life, things just start changing, bit rot, right? We all call it kind of bit rot, and when it sits on the shelf for a while. Well, the other interesting effect is when you introduce new changing environments to automation, you need to be able to adjust that automation quickly. And since our platform is built on a modular composable construct in an infrastructure as code way, we also reveal jobs that fail very quickly. We alert and modify and monitor what's going on and give you the ability to debug what's happening. So when we'd start putting that new equipment through its paces, it was very apparent where things were breaking quickly. We could go back through the infrastructure as code components, adjust those quickly, and then iterate over it again. And consequently, we're able to reduce the amount of time it took them to onboard new equipment very quickly. And in a lot of cases, this pushed back on the hardware vendors, because the hardware vendors would be like, oh, well, yes, it's a new platform and you expose these new interesting, we shouldn't say bugs, but behaviors in the platform. And so it helped us both from the vendor story and being able to prove out vendor equipment quickly. It helped with the customer story to be able to turn over new equipment much more quickly and onboard it in a very fast manner and be using it much more quickly.
This is a really good example of just how much we can improve everybody's outcome with this type of collaboration. And it's worth noting that while this was driven by one vendor who wanted to get equipment into production faster, because it was done in a repeatable, generic way, everybody in the pipeline got the benefit. And this is one of the things that we do and focus on a lot is this infrastructure as code, this catalog, and the reusability of the systems means that when we fix automation for one customer, right, when we improve the integration between a vendor and production, we actually have that benefit for everybody. So the vendor here, the OEM, actually can make their systems available faster to everybody in market and turn things over more quickly. And that is actually a really significant benefit back to the OEMs.
Would you say that your customer base is more, I mean, I know it's both, right? But more cloud or more on-prem?
We're more on-prem.
More on-prem, okay.
Proudly, yeah.
Yeah.
So I've tried to automate bare metal things in the past. And the problem that I've always encountered is the fact that even with 4 different systems that were ordered from the same OEM with the same specs are not identical systems.
Correct.
And so the script that worked on the first 3 fails on the 4th because the firmware version's slightly different. They sourced the NIC from a different place, whatever. So like, how are you dealing with the vagaries of bare metal provisioning when systems are not going to be the same?
This is heterogeneity and complexity are assumed for RackN. So when we started our architectural journey, we did the opposite of what most enterprises do, which is they assume they can beat complexity by simplifying and selecting less stuff. So most companies that we talk to have said, you know what, we don't need a sophisticated provisioning infrastructure because we only buy X vendor, right? And you're exactly right. Even if you buy only from X vendor, their life cycle changes, their provisioning cycles change. They switch from legacy BIOS to UEFI BIOS, right? There's always something in here. They switch their NIC patterns. There's something. And that heterogeneity, we built it into our assumptions about the system. And so when we deal with any new piece of infrastructure, we actually already have the architecture in place to deal with the fact that they're not all the same. And then we spend a lot of time making sure that they're very safe paths through the product and then can accommodate the variations, detect, adjust, and then adapt to it. But that's what lets us do things with and without inbound automation, right? So you can, if you have iDRACs or ILOs or whatever the control process is, we can adapt to that. So like Raspberry Pis, we can automate everything from that to cloud infrastructure and treat it in a very abstracted way. I'm going to talk about abstraction in a minute and how important it is. But that's the key, is finding the right abstractions and then driving declarative APIs behind the scenes.
Gotcha. Another big concern about anything that is doing bare metal provisioning is the chain of trust and security in that provisioning process. Because if you have access to the bare metal, you can embed all kinds of funky stuff that was undetectable by the operating system that you lay on top of it, or if it's a hypervisor, the VMs above that, because it lives at such a low level. So we really got to trust that your software is safe and secure, and somebody can't inject malware or something inside of your software and deliver that to 100 servers in my data center.
It's interesting. I agree with you. One of the things that we did years ago now and try to promote for our customers as much as possible is secure boot integration. So you can use secure boot processes, you can get secure kernels. Unfortunately, we don't see a lot of uptake in those systems because once you've turned on secure boot, it's very hard to regress. So you have to have a very resilient infrastructure to turn on those pieces. We do. It's one of the reasons why we have high availability from a provisioning perspective, which is unheard of, right? It's a lot of the ways in which we build these systems enables you to turn on security features that most people don't turn on in their infrastructure. It's really drives us nuts. I love to bang on the table. The other thing that's important is to have processes to quickly patch, update, and restore, right? That average system age. The thing that people have to realize is part of the reason why you want a short system age means that you've gone through and patched and updated the BIOS and reset the system and installed the latest OS. A lot of that security issue is not from getting penetrated, right, on the latest stuff. It's actually from not keeping up with patches and changes. That's actually the bigger risk. We're about to, one of the features coming in this next release for us is the ability to do out-of-band scans. And we're helping banks do compliance audits where they can check all the systems, even ones that weren't controlled by RackN, and do a scan, check, and remediate to make sure they're up to date. Most people don't even know how out of date they are. So no, these are very serious problems. And the solution is simple, but requires you to have a pretty reliable, now we're back to available, right, reliable and fast. Because if you're not those three things, then the idea of rolling a patch through, even 100 servers becomes really scary, right?
Yeah.
So you have to be you have to be confident. This is what the coffee break story is so powerful, because if you couldn't push that button and expect it to complete in an hour, you would not be taking a coffee break while the systems did that work, right? You'd be sitting there babying it or running down to the data center with your USB drive because you knew you were going to have to fix something. And that's the way sadly, most enterprise systems are. They don't have to be, but they are.
Hey, Rob, you're talking about infrastructure and bare metal generically. Are we just talking about a compute platform? Is that essentially it? Or would there be network switches that you might provision as well?
I love that. Yeah, there are. And we can do, we have customers doing network switch and storage arrays. More storage arrays because they're really compute platforms with fancy software on them. The biggest challenge here is actually political. Inside of organizations rather than RackN's capabilities here. We generally come in through the compute side.
Yeah.
And the network side is at war with the compute side.
War is a strong word.
They have a family feud.
I'd say maybe not strong enough.
And so right, that Hatfield-McCoy thing does play out where they, we're slowly getting there. We have some really nice like LDP integrations, and we have a whole bunch of ways that we can control and integrate to switch fabrics and switch systems, and provision switches. This is something as edge matures a little bit more, we're going to see more interest in that, because an edge system really does need to be a drop infrastructure from an airplane and have everything go.
Yes.
But yeah, in the enterprise space, the switch teams, they do not relate, do not have coffee breaks.
Not because you can't or won't, just the politics of it.
That's been the biggest challenge for us.
Yeah.
When you brought up the good point of I used to, when VMware first had their right click remediate, I would do it at 11 in the morning on Tuesday, and people are like, "Are you nuts?" I'm like, "If I can't do it, why is it there?" And I was a bit of a leader in idiocy that I was willing to take the risk. But if you can't trust it, then why should it be there? And that's what I've loved about your idea is you should be able to reset this machine, shorten the life of this machine, so then for sure it's more closer to immutability.
Yep.
Doesn't need to be completely immutable, but it's let's tighten the window.
One of our first customers here was somebody who had 40,000 machines in three 40,000 machine data centers. And they had a 4-hour window every month where they could roll through their patch.
Yeah.
It was tiny. And the problem is that they had a 20% failure rate in that window. So even if they could have made the 4-hour time, they couldn't. And so when we showed up, we were actually not only faster than the 4 hours, but our failure rates were well under 1%. And that in itself was just a dramatic thing, right? If you lose 20% of a cluster, and then you have people running around trying to fix it, that's crazy hard.
Right.
And even more importantly, I think, is that 1% failure rate, which is what pulls sysadmins' hairs out. You're just, why is this failing? And it's inevitable. Hardware will fail. There will be problems. And exposing those failures very quickly and raising those alerts very quickly allowed them to home in on those problems and determine was it hardware, was it network, was it software, was it the automation, didn't catch some variation, and then it allowed them to correct those and remediate those issues.
When you have a path to do it, which is the biggest problem right now, we have this resistance to if it goes wrong, then the first human instinct is then let's just not do that again.
Right.
And then let's take a really long time to evaluate how we could do it better versus look, something went wrong. We knew exactly what went wrong. We can take a run at it again because you've got, safe rollbacks, you've got auditing, you've got health checks, you've got canary style deployments.
And one of the things that we're going to show when we get to these demos, in both cases, when you interact with the operational APIs, you have the operational side of the business has incredibly good transparency into what's actually happening. So it's not somebody ran Terraform and I have to go walk over to their desks and hope they have the state file in a place where I can see it. The way we're doing these interactions, you can actually watch all that infrastructure get built. And that is transformative because now the operations team can actually log in and see what happened, can remediate things if something went wrong, right? We're actually putting the control back in here. There's another point I wanted to make, and then I'll keep diving through the slides, is that if it's confusing why RackN is a software company and not a SaaS, here's the very, very simple thing to understand. Nobody wants you to change their automation for them. So if we were a SaaS and actually involved in deciding when our customers' automation changed, we could be breaking them and they wouldn't know. Part of the idea here is that when you're running infrastructure and you're depending on automation, you need to be in control of when that automation changes. And big part of what RackN does is that we are keeping our customers in control. Now they can take all that infrastructure as a patch upgrade, perfectly fine. They stay on the bus, but they choose when that happens. So we're not Friday afternoon deciding, oh, it's time for us to patch this bug for this other customer, and oops, all of our other customers got taken out because of it. Every customer is in control of their own environment. That's why we were a software company. So I do want to talk through this dev versus ops tool sprawl. And we see this over and over again. And part of platform engineering is to actually embrace this. So what we see is that there are many developer platforms, and there will be. That's okay. But from an operations perspective, the teams need to consolidate down into one thing, right? We don't want to have operations chasing each cloud as a bespoke thing, or each software or server vendor, or each data center as a bespoke thing. So the idea here is that we want to embrace a view where every development team uses the tools they want. Now, I'm not advocating that they all should be different just to be spiteful with each other. If you can standardize on one IDP or one CI/CD system or one platform, that's great. But even if you were to standardize, say, on Kubernetes, most companies are doing multi-cluster Kubernetes, right? So there's 1,000 clusters out there. So you have Kubernetes from different vendors, different versions, different ops, right? So even if you said we are a Kubernetes shop or a Terraform shop or a Backstage shop, you are likely going to have different environments with different setups, all talking back to your infrastructure. And you don't want the ops teams to have to chase each one of those as a bespoke, special way to interface with infrastructure. And that's really what we're talking about here. Being able to have a consistent operational experience that you can then build on and then not get in the way of those stream-aligned teams. Another way to look at that, and I really like this sort of as a framing, is the platform engineer has 3 different areas where they have to worry about things. One is the infrastructure and the automation side. That's where RackN really shines. But they also get requests to build control platforms. We're going to demo Backstage for that, or service orchestration. We're going to demonstrate Terraform and talk through some CI/CD use cases in this case. And the idea is not to make all those things one platform and only make everybody use one tool, but to have places where we get consolidation in the infrastructure side and embrace the fact that there's variation on the consumers of that infrastructure. So I do want to spend a little bit of time before we dive in demos, giving you some background on digital rebar proper. We've talked about the problems. We've really talked about how enterprises consume. But I know y'all are technologists, and I do want to explain what we do a little bit. We are a vendor-neutral infrastructure as code automation platform. Super buzzwordy. I know, but that's a fair, right? This is really what we're doing. We help manage infrastructure and make all this stuff work. And things I'm really focusing on here is it's an enterprise product, so we're enterprise grade. We do have the fancy features like single sign-on and HA. We're self-managed. I've talked about that. And one of the things that we find very interesting to customers, although they interpret it all sorts of ways, is that we do have air gap capability, meaning there's no RackN tether. There's no requirement that we come into people's firewall. They can run this completely on their own. Depending on how much pain they want, they can air gap it everywhere from a little bit to a lot.
Rob, when
Yep.
you say air gapped,
Uh-huh.
that term has been abused a little bit.
It has.
What do you mean air gapped?
When I say air gapped, I mean military grade air gapping. which means that you actually have a system that has absolutely no outside communication with anything else. It is a completely self-contained infrastructure, right? The only way to get data in and out of it is with a USB drive, right? Physically walking that infrastructure in. When our customers talk about air gap, they have a wider range than that. A lot of them mean no inbound connection, but they do allow outbound connection. And so, yeah, I agree with you. It's an abused term from that perspective. Since we support the hardest, we sort of just nod through when somebody says, "Oh, I'm air gapped," and here's my proxy server.
Yeah, I've got 17 Bastion hosts and sitting in my environment. They're like, hey, it's not really air gapped.
But we've done the hard work and we spend a lot of time building infrastructure as code components. So one of the things that's nice is even if you are lightly air gapped, the way we build infrastructure as code is you can completely define a site and zip it up into a file. All the automation, all the profiles, all the configurations, you can put it in a zip file and show up on site and unzip it, and then you have a completely working site.
Okay.
Right. And so that capability really shows up. Actually, it's a core part of our multi-site pieces, because even if your multi-site was completely connected, then you would still be able to have every site be autonomous. And that's how we treat multi-site.
Okay.
Hey, Rob.
Yeah. Hey, Larry.
So on the air gap thing, I know it's not part of today, I guess, but can we touch on that later on at some point?
Sure. You'd like to.
On what that means, kind of like taking a use case of like dropping a Raspberry Pi in with RackN, basically managing the whole infrastructure. Is that something that Shane's going to demo today or anything like that, or talk about? Or?
No.
Am I hoping for too much?
It's almost impossible to demo a air-gapped environment, as you know. But we can talk through sort of how we deliver all of an environment into a set piece. We're happy to add that into the discussion.
We'll save that for later, but that would be good because obviously you're hitting on that. So that's something that would be pretty interesting.
It's what people need to understand with this is that the reason RackN works, the whole digital rebar architecture, is designed around this idea of immutable infrastructure as code automation, right? It's actually one of the key things on this. And when I say an immutable workflow, that means it's version controlled, it's not changeable in production, it is delivered as a composable unit. And that immutability is what allows us to replicate sites. It's what allows us to give customers new versions of software, because we can say, here is the parts of your workflow that we have patched and updated, and here are the parts that you have customized and changed, and then compose them together. So all of that works together. That's actually the key, one of the keys to the air gap capabilities here. And it's part of the reason that we treat this all as software. So what I'm showing you on the screen, just to give you a little bit of a basis here, is this is the RackN space capsule. What we have is a declarative API. I promise you I'd define what that means. Machine for us is one of our key abstraction points. So you can describe a machine with nothing but a name if you need to, right? And what would happen is that as that machine goes through a workflow, we collect more and more data about that machine. Right. So the declarative part is I can take a machine, I can tell you what I want to know about it, what pipeline I want it to run, or what BIOS patch I need, or my SSH key. I can attach it to that machine and then let the workflow accumulate all of the other information. So I'm declaring the minimum pieces I need, and then we actually accumulate the data. If you're used to something like Ansible, where you have to know everything in advance before you can even start that work, this is the opposite of that. We're actually designed to accumulate information as that workflow progresses. Okay. And then what we add on top of that is the concept of this infrastructure pipeline. So pipelines allow us to couple workflows together and then put logic in between that coupling. So we can detect what type of machine it is and treat cloud and virtual and hardware machines differently, or Dell and HP and Lenovo differently. So we can actually go through a process where the workflows that get called are appropriate to that environment. Okay. Yeah.
And so that actually goes back dovetails very nicely into one of the previous questions, which is the hardware vendor may change components within the hardware platforms that are delivered to you, you don't know. And that composability is what allows us to apply new change but also importantly, the collecting information as we go along, deep inspection of the equipment that's been brought on board. We have a tremendous amount of detail value that we can iterate over and make decisions based on and pull out those changed details and then apply appropriate changes to correct whatever needs to be corrected to make that new platform or that new hardware change operational.
You want to keep going and describe the composable pipelines piece? Or do you, or you hand it back? It's up to you. All right, I'll take it back. So what Shane is talking about is part of the concept. What we've actually done is, because there is so much similarity, this is a personal pet peeve of mine over my career. People are building infrastructure from the same components, with installing the same operating systems, right, using the same tools, but they end up with different data centers. And it's silly, but it's the way we approach the automation. And what RackN has done is we've solved that problem. When we build our pipelines, we don't just chain automation together, we actually chain automation together in a predictable way. So every stage of that workflow has known preconditioned, pre-operational steps that allow customers to do their own specialized classification, checking of systems. They can validate what's going on. They can add pre-processing tasks if they want. So imagine you were doing an ESXi install and we didn't have built-in capability for the thing you wanted to do to that hardware. At this point with ESXi, that's hard to imagine, but you want to do something in the hardware that we don't do out of the box. You can add a task to do that without changing our ESXi workflows. And when we patch and improve that workflow, your task will ride along because it's been injected into a standard point. Because nobody should be writing custom ESXi installs, even though most people have, right? The idea is we've been able to take, and I'm just pointing on ESXi, we have the same for Windows, we have the same for Linux, we have the same for pretty much any hardware, any operating system, any cloud, but that standard process that you get to go through, and then you add in just the little pieces that you need, and because we have known places to do it, we know where people are adding, and people are able to take patches and upgrade and stay in the pipelines because they've been able to wedge into known extension points. It's a really powerful concept. And this is something that we've just seen explode for our customers. We start with so much out of the box capability, and then they really don't have to change what's going on. We even have a graph for this in the UX.
Have you seen the same questions or potential for Hyper-V implementations? I'm saying this as like I've spent so much time in VMware and cloud and Kubernetes that I just don't bother talking to the Microsoft kids to see if Hyper-V is a prevalent platform in enterprise today.
We do have a financial sector services company that actually runs both ESXi, VMware Stack, side by side with Hyper-V Stack pieces. The thing about Hyper-V is it's basically just Windows.
Right.
And so if you're automating Windows, it's a package and some minor configuration on top of that. ESXi is significantly different. It's essentially its own thing, even though it's very Linux-like.
Right.
Under the hood, inside the box. So those are the core differences. The uptake on Hyper-V, it's there, but I don't see it as much prevalent in the on-prem data center stories.
That's great.
That we're in touch with.
I was gonna like joke at him. I'm like, I hear more of people, using it. It's just that I haven't been in those environments.
Every time I present, ask how many people are on Hyper-V, one person raises their hand. It never matters. It's always one person. Maybe they work for really big shops, but
Or they just meant their laptop.
There's definitely always somebody who's like, oh, I didn't have to pay for this. I can just download the license and make it go. And we definitely see things like that. The other thing I want to point out with this, and this is useful, and I think we actually have a whole Cloud Field Day 15 presentation talking about this feature. So it's a significant feature on its own. One of the things that we support, I've been talking about workflows and pipelines quite a bit, but that same automation can be used in an asynchronous way for day 2 operations. So we take the exact same code and blocks and tasks, and you can do ad hoc requests against machines also. And it's not just machines, actually, it's clusters and other resource API pieces. But the power of this, since we added this feature a couple of releases ago, is tremendous. You can schedule work, you can create triggers, you can do all sorts of ad hoc. Oh, I just need you to run a security scan or do this patch. There's actually an API and a queuing mechanism behind, I just need to do this one thing. Can you please do this for me? You don't have to pass systems through a full workflow. As important as it is to have workflows, it's actually equally important to be able to just issue a asynchronous task, have it queued so you know it's going to happen, and then count on it being able to do that work. Right. And then everything we do is audited, job logged, has very good controls around it, so you can actually see what's going on in systems. You had a question?
I have two questions around your workflow management. How do you handle dependency graphing? And what about parallel task execution?
Dependency graph is there's a lot of ways to answer that. What do you mean?
Well, I'm thinking of how does it determine the order in which the steps have to be done on a particular system or group of systems to accomplish the end state that you want?
Okay.
And if it determines there's not a dependency, will it be greedy and try to do those tasks in parallel?
The way the system works is that each machine has a runner, and that runner is parallelized for the machine. On the machine itself, they're sequential.
Okay.
Right. The thing that's really unique about us is that we have the ability to run actions on the machine and then run them without violating the sequential and the state information, run them back on the digital rebar endpoint or server also. So you can interweave tasks that have to happen on a machine and tasks that have to happen off of a machine. The simplest one for people to think about is an Ansible playbook. You could run either on the machine in local mode or remote from the machine using SSH. But that could be your switch configuration. If you had to make a switch config for a machine, you could actually have the machine make a switch config. Or when we run Terraform, we're running it from the endpoint, not on the machines, because the machines don't exist yet. Right. So we're able to actually bounce these back and forth and then execute them sequentially. When you need to do something that's coordinating multiple machines, we have a cluster concept. It's actually an ephemeral instance that can still run workloads and work streams and work orders. And so when I'm coordinating a bunch of machines, I actually do that as a cluster. And then the cluster can make decisions about which machines to coordinate in which sequence. And then we don't have to deal with tracking individual machines making decisions. We can let the clusters have built-in logic for this. They can say, oh, wait until all my machines reach an endpoint and then continue doing my work. Or wait until these machines the leaders reach an endpoint and I can do that work first and then wait for the workers to come in after. So the cluster, having that cluster concept, which is also really unique from an infrastructure operations perspective, allows us to do all sorts of work. I can even have empty clusters. And so if I needed to schedule work and start building credentials and things like that, I could take a cluster with no resources in it, do pre-work for that system, and then add machines once I need them. I'll show that in the backstage video. And then the same thing is true if I delete a cluster, then it'll destroy the resources that are assigned to it. So we used to try and do things where machines would coordinate more. Once we added the cluster concept, it really transformed how we think about multi-machine operations. And it really gave us a nice place when we run Terraform plans. Terraform plans are actually a cluster level operation, and then they create resources that get assigned into the cluster. There's a couple of pretty high level concepts, but they're very powerful. Cool. I've been talking about edge and multi-site. It's always nice to just, one of the things here and what we see is it's not just about running a site. It's actually about having consistency across multiple sites. And we have this concept of Multisite Manager that we highlighted in Cloud Field Day 13, if you want to go back to our demos, where we actually showed how you can handle distributed control across multiple sites. And all that ties into this air gap distributed capability. One of the things that's really nice about this is it actually pulls all the infrastructure from each site into the manager or managers. You can have multiple, and you can create API calls at the management layer that then are distributed to the endpoints. Incredibly powerful. We have some customers who are spinning this up for cell phone tower global management or global data center infrastructure. This is an eye chart, and I'm not going to go through all the pieces. This is a high-level architecture. If we need to come back to it, we can talk it through. But fundamentally, we have a state system, we have provision and orchestration controls, and everything ends up being rendered as a template. There's no magic in the system. So for this sort of not that brief intro on what we're talking about, I want to go through, we do have some key takeaways, right? This is about an infrastructure platform, the complement of a developer or an IDP platform. It has to be available, reliable, and fast, or you're really not servicing those needs and people will bypass you. The key to making that work is that you have to be reusable and standardized in how that infrastructure works. Otherwise, you're going to be chasing a whole bunch of fractured systems, which is where most people are today. And that prevents you from consolidating operations. Right. And what we really see the primary benefit here is that to encourage innovation, operators have to be doing less work, getting out of the way more. That's the theme for platform engineering.